Hey guys, hoping all is well with everyone. So in my last video with our question of the day, we looked at this equation solving for j, in which 12.6j plus 8 equals 10.2j plus 4.4. And I kind of established the big elephant in the room right off the bat, being that there is a lot thrown at you in terms of this question. In not only that is it a double-sided variable equation, but it also has the component of decimals. And it also futuristically looks at the addition and subtraction of both positive and negative numbers, those numbers also being decimals. So upon reflection, I looked at another method in terms of how to approach this. And this one more just kind of grabs the bull by the horns and eliminates the idea of decimals right off the get-go. Now, because of that, you're still going to deal with fractions, but in our approach to solving this equation, I feel like it's a lot more cleaner, which is why I wanted to take the time to kind of go through this method too. So the first step that I'm going to take with solving this equation is going to be by eliminating all of the decimal component of this right off the bat. And the way that I'm going to do that is by multiplying both sides of the equation by a factor of 10. And that's going to create some decimal movements that will allow all of these terms to be whole numbers. So step one is going to be eliminate the decimal component of the equation by multiplying both sides by 10. So let's go ahead and do that. So we have 10 multiplied by, and remember when we do this we have to treat it like the distribution of 10, so we want to be really careful and organized with that. When I do these questions of the day and these equations, I always talk about what can really set you up for success, about keeping account of all of your terms and what's happening to them as you go step by step. And remember, we want to apply this balance scale kind of analogy with making sure that we're applying operations to both sides. Oops. This is 10.2j. So the beauty of this is going to be to make all of these terms with coefficients or constants that are whole numbers. So remember, with our distributive property, it's going to be distributing by multiplying each of the terms in parentheses by the coefficient on the outside. So this is going to now become another step that we can take. So step 2 is simplify both sides of the equation by distributing 10. So this is going to give us 126j plus 80 is equal to 102j plus 44. So there's some happiness and joy already taking place here for a lot of students out there that aren't the biggest fans of decimals. And again, this kind of comes down to what you're most comfortable with. So the next step that we're going to take is we want to go back to our bigger picture goal, which is getting the variable on both sides. So what we're going to do that is, with step 3, get variable terms on both sides by subtracting 102j from both. Oops, sorry, this is get variable terms on one side. My apologies. So we're going to subtract 102j from both sides. So when we do that, we're still applying that kind of balance scale kind of approach. So we can take a step 4 and simplify, just have that simplification step. So here we have 126j minus 102j. So remember, for intents and purposes of this question, the like terms are going to be all of your constants or whole numbers without variables, and then any terms that involve the variable j will also be combinable terms. So 126j minus 102j is going to be 24j plus 80 equals, and then again on the right side, that 102j minus 102j is going to cancel out. And we talked about last time how you can put a 0 as a placeholder here just to see where your terms are going and how they are canceling. That way you can just kind of make sure we're staying nice and organized. So this is going to be 44. I'm kind of old-fashioned. I usually do the 4s like this. But I love how I said that, and then on the left side, I did it like this. Okay, the next step that we're going to take, so now we've accomplished that goal of getting the variable on one single side. So now we're going to start to isolate it. So the way that we're going to do that is, for step number 5, begin to isolate the variable by subtracting 80 from both sides. Now, if you guys are picking up on this as we're going, what you're going to notice is that we're going to start to see some numbers kind of come back here in reference to the previous video. So last time what we did was at the very end to make the final quotient not involve decimals, because it was negative 3.6 over positive 2.4. We took a final step and multiplied the top and bottom by a common ratio of 10, which gave us negative 36 over 24. But in this method, we're starting off by multiplying everything by 10 right off the get-go in the beginning, which eliminates the decimal right off the bat. So if we go ahead and do a simplification step, so we'll do that step 6 again, or a simplification step. Simplify, combining like terms. So if we do that, we have that 24j, and again, this plus 80 and minus 80 will cancel, and again, we want that, but you can definitely use that plus 0 as a placeholder. And then 44 minus 80 kind of goes back to that addition and subtraction approach with positive and negative numbers. So this again comes back to what's most comfortable for you. You can either approach it as positive 44 minus 80, or you can take the approach of negative 80 plus 44. Now, one question or kind of comment that I got about this is that, can you use a number line to visualize your operation? And the answer to that is absolutely. However, I will caution you only slightly, because as you go further and further down the road of your mathematical journey, you will notice that the number line starts to have its limitations in terms of how helpful it is, because as your numbers get larger and larger and more specific, especially with decimals, you're gonna find it to be a little bit less helpful. But in this situation, if you're just trying to figure out like the final signage on your arithmetic here, that's totally fine. There's nothing wrong with that. But again, your resultant will be negative 36. So then I'm going to take this one step further, and then I'll just do 24j is equal to negative 36. So now, in the previous video, this is kind of the multiplicative of 10 of where we were originally before. We were originally at 2.4j is equal to negative 3.6. So this kind of just goes to show that whatever path that you take what is most comfortable for you. In this case, we're not dealing with any decimals, which is kind of happiness and joy for a lot of students. So then our final step here will be to divide both sides by 24 to get j completely by itself. So step 7, completely isolate the variable by dividing both sides by 24. And then here, we kind of are now back to our final situation after simplifying, but we get that 24j divided by 24 is 1j, but remember, because of that identity of multiplying by 1j is just equal to j, so we've accomplished our goal of getting j completely by itself. And then we have negative 36 over 24. Now, the only elephant in the room left with this question is that this most likely won't be a possible answer choice if this is a standardized exam question or like a question on a test. And the reason for that is because they're going to want it in reduced fraction or simplest form. So the way that we're going to do that is just by reducing it by dividing the top and bottom by the greatest common factor. So in this case, if you use factor trees or any other kind of method that you're familiar with, some people call them like factor branches. But your final step here will be to simplify the final fraction by reducing it via its GCF, or greatest common factor. And the last time we deciphered that the greatest common factor here will be negative or positive 12. Which brings up a good point. You can also say there's a greatest factor of negative 12, but again, you would just force the sign errors, or force the sign changes. So this would just become negative 36 divided by 12 is negative 3, divided by, or over 24 divided by 12, which is 2, giving us that j is equal to, again, that 3/2. So again, the goal of this video was just for you guys to be able to see another method that you can take with solving this equation. I think this one is a lot more cleaner after kind of reflecting, because right away it kind of, again, just grabs the biggest overwhelming factor for a lot of students on this question, being the decimals. But I hope this helps you guys out, and again, if you have another method that you can take to approach this question, I would love to see them. I always like to see different approaches that students take to solve these types of equations. But I hope you guys are doing well. Please take good care and be safe, and thank you so much for watching, and we look forward to seeing you guys soon. Bye.